Thank you. I was asked to talk in this presentation about the challenges and strategies on management of food processes in a zero-risk environment. And I'll talk a little bit and review a little bit of about some of the previous speakers have talked about on what zero risk really means or doesn't mean. I think we've had some really good discussions on that. But then pivot into how we have to manage to that for regulatory compliance, but also to make sure that we're meeting our understanding of the way that the consumers behave. But I want to talk first of all about the world that we live in. I think these are things that we already know. Chemical analyses have become more and more sensitive. We've moved from parts per thousand to parts per million to parts per billion, and we're on our way to parts per trillion. What does this mean in terms of what zero is? If zero is absence, how do we define absence? How do we determine absence? And when we get more sensitivity, we begin to see things that maybe we didn't see before. And these might not indicate greater risk, but it certainly makes it more difficult to meet a performance standard of absence when the when what absence means is changing based upon the analytical method. This can apply on the chemical side, but also many of the methods that we're working on in microbiology are driving down the sensitivity of what we can see in food samples based upon how many copies are needed or how many bacteria are needed for detection. So while on the chemistry side we have a lot of precision, we're growing in precision on the microbiology side as well. We had Dr. Coughlin talked about whole genome sequencing. I put up this slide. Ruth Petran gave this to me. She was describing to me the example of vehicle identification numbers. And it used to be, before I think 1952, that the way that you could trace or identify a car would be through the registration and then records on where people purchased the car. But there wasn't a lot of precision in terms of how you could determine, if you find a car along the side of the street, if you could determine where that car was from and more detailed information about the car. So in 1952, and then formalized in 1981 or standardized in 1981, car manufacturers put in place a vehicle identification number that gives a lot of information about the vehicle that we didn't previously know. There are things like the country of manufacture, the type of manufacturer, the manufacturer number, descriptors of the model and body style, the year it was assembled, the assembly plant, and even the production, and then the production number of the unit itself. So we now have a lot greater detail than we had before on where the car was manufactured and the nature of the car. And this, if we think of whole genome sequencing and then some of the things we're seeing on even metagenomics and the microbiomes and environments, we're getting a lot more information and detail on the nature of the organisms we're looking at for microbiological hazards. This is evolving, but it's being more commonly used because it's becoming cheaper and easier and more readily available. We also have changes in cultural techniques that are allowing us to identify, like I said, lower numbers of bacteria, but also multiple types in single analyses. The net is that we're seeing with more precision outbreaks that we didn't see before. So things that were sporadic, what was seen as sporadic cases of listeriosis up until recently, now are being identified as outbreaks, even though those are outbreaks with maybe only a few cases. So you see on this graph it shows that the risk of listeria has kind of plateaued. This is in the US, or the number of cases of listeriosis has plateaued, but we're seeing greater and greater outbreaks with the evolution of technologies and precision of the methods that we're able to use to identify whether these outbreaks occur. So from a food safety manager, this then identifies, we're now identifying more and more vehicles or common sources of foodborne illness that we maybe didn't see before, and things that we thought were low risk because we weren't seeing issues. Now we're seeing that maybe these are linked to outbreaks, and we're getting source attribution that is identifying some of these vehicles that we didn't see before. And I'm going to give you a couple of examples. One that's near and dear to my heart is cookie dough. When I was with Nestlé, I was involved in the cookie dough recall that was associated with the outbreak that the CDC identified along with several state health departments through pulse field gel electrophoresis and some other genetic techniques. This was something that had not been seen before. It was novel. The product had been designed to take care of the risks in a lot of the raw materials in the product, with the exception of flour, because flour was something that was normally used in baked goods. There wasn't historically a lot of ways to eliminate microbiological risk in flour, and frankly, people just inherently did not see flour as being a risk. So as a result of that, we did identify that flour was the likely cause of the E. coli 0157H7 in cookie dough, and we were able to re-engineer to incorporate a flour that was heat treated. Since then, we've seen a couple of outbreaks, one in 2016 and one in 2017 related to E. coli 0121 in flour. And if I think about this, this causes a number of challenges for risk managers. First of all, we were able to use heat-treated flour in cookie dough because cookie dough doesn't need to rise. Now, that's a simple assessment because there was a lot of work that had to go into engineering the flour to make sure the cookie looked like a cookie at the end of the process. But it's not a cake or a croissant or another baked good that needs to rise where we need gluten functionality. And so if I apply what we've had to date as a technology for dealing with pathogens in flour, I destroy that functionality, and I'm either left with the decision, do I tell the consumer we don't trust you to use flour to cook your cake and not make it available to them? Or do I understand that there's a certain risk and work as best as I can to try to minimize a risk I know I can't absolutely control? And that's some of the challenge we're facing as risk managers, and I've got some other examples of that. I put also on this slide the cake mix, and I thought this was an interesting example for risk managers as well. Cake mixes were recalled as part of the outbreak, and cake mixes are things that are products that have validated cooking instructions for consumers. There was a recent recall of milk powder that also led to the recall of similar products. And as a risk manager, this makes things challenging. In my HACCP study, I look at consumer use, and I design my product accordingly, and likewise, I design the way that I manage the risk related to my raw materials. In the milk powder case, I may have assumed that it was low risk because anyway the consumer was going to cook my product, and so I wasn't evaluating that milk powder manufacturer for salmonella control with the same stringency I would if I was using milk powder in a cold beverage mix. And that causes some challenges, because if there's a recall from that milk powder manufacturer, or there's a recall of the flour manufacturer, I'm now included in the recall because I don't have my own control measure in place. I'm relying on the consumer. That changes the whole way that I have to do my raw material risk assessment, because now I'm not just assessing the consumer behavior or how the product's being used. I'm having to assess what are the implications if one of these suppliers fails, if the raw material fails. Another recall that was notable and kind of a game changer was an outbreak related to frozen vegetables. There was a couple manufacturers that were associated with this in Washington State. And up until this point, there'd really been no documented illnesses related to frozen vegetables. But there was a discussion as to whether how frozen vegetables were being used, and whether frozen vegetables and similar products were being used inconsistent with how they were labeled. So they were labeled with cooking instructions that were validated, but nevertheless people perceived these products as being something that didn't need to be cooked. And we're seeing this more and more as we investigate consumer behavior. Consumers are reacting more to how they perceive the product could be used than what is labeled on the package. And I think after the 2009 cookie dough recall, I was talking to a colleague of mine from another food company that had had similar recalls on similar products, on other frozen culinary products, and they said they had done some work with consumers to understand consumer perceptions, and their conclusion was nobody under 19 reads the label. So we have to look at how our products are perceived and whether it's obvious that those products need to be cooked or not as we do our assessment of risk and as we design the products. There's also some cases where we know the standard, The previous cases, I guess, are where we have to reconsider what the standard is or what the expectation is for the product. But we see products where we know what the expectation is, but now we see that there's other factors we didn't consider for risk. So caramel apple, this is one certainly we don't want to have a Listeria risk in caramel apples for consumers. But when we had this recent outbreak, we saw that there were some risk factors we really hadn't thought about in how some of these caramel apples were being marketed and distributed and stored. And so the factors involved in manufacturing these apples, in storing them the way that they were stored, led to a growth of a high level of Listeria and led to a consideration that we hadn't really thought of up till then on how we should be managing caramel apples. When in retrospect, we can see how those risks could occur. This table is something we've been talking with some of our colleagues in industry on how we assess consumer perception as we evaluate whether or not products would be ready to eat or products would be not ready to eat, but products that we still need to manage risk. And so I've listed here some drivers, and I apologize, this is an eye chart. I wanted to show that this was more of a decision tree, but I'll just read down what some of the questions are. So some of the questions we would ask is, first of all, is the product intended to be consumed without application of a cooking step by the consumer or food service operator? That's a no-brainer. That means we intended for it to be ready to eat. But other questions, the product will be consumed by a consumer or food service segment that views the application of a validated cooking step unnecessary. And that could be Toll House cookie dough. What we saw after we had the outbreak, we were off the market and there was highly publicized outbreak, do not eat raw cookie dough, and the FDA said this and Nestlé said this, but nevertheless there were blogger groups that insisted it was their right to eat raw cookie dough and they would accept the risk. And the problem is, they might accept the risk, but if they get sick, the FDA have to take action regardless of if the FDA thinks they messed up, and we are responsible regardless of if we labeled it appropriately. So that's the kind of risk management paradigm we're in. So we have to look at how the consumer perceives it, and things like soup mixes, which could be added to just hot water or added to, I guess, mayonnaise to make a nice dip. Those are things we have to consider with this question. There's another question, products appear to the consumer to be in a form edible for consumption without cooking. These could be the chicken Kievs that we've seen responsible for some salmonella outbreaks. They're raw chicken, but they appear to be fully cooked. So we have to consider that as a question. Products in a form normally consumed without cooking. So if I've decided I've got cinnamon rolls and I'm going to market a frozen cinnamon roll, I can't just decide, or it's not good to just decide, well, we're going to make it not ready to eat and tell consumers to cook it when it looks fully cooked. And they normally consume something fully cooked. So that's a consideration. Then we look at chilled products and their shelf life and whether within the shelf life pathogens can grow at unsafe levels. And then we look at variability of cooking equipment. So this is an example, and it's kind of a draft that we've been working on with our product developers in the past, but it kind of lists the questions that we have to think about as risk managers as we design products. But we have a changing risk management paradigm, and I'm going to direct people to a session tomorrow on Listeria criteria. And there's some of the speakers there can talk to the evolution of the regulatory agencies thinking on what appropriate levels of Listeria are in products. But I wanted to talk about this briefly because this really impacts how we have to manage certain products and what we need to consider as we manage certain products for the presence or levels of Listeria. In 2011, there had been in the past, there were some very good Listeria risk assessments done by FDA and FSIS, and there was another one by WHO and FAO. And generally, the conclusions are Listeria needs to grow to high levels to cause illness, and that's how they concluded and ranked the products accordingly. In 2011, there was a dose response workshop that was hosted by Joint Institute of Food Safety and Applied Nutrition and the Interagency Risk Assessment Consortium, and they came up with a number of things that would make the dose response calculations more effective. What are the data needs? What are the approaches we should take? And a group of scientists took about reassessing some of the dose response information, and this was their conclusion. And I'm going to direct you really to the bottom, is that the conclusion predicted that in fact there were a low percentage of cases, but still a percentage of cases that they would attribute to levels below 100 CFU per gram or 100 CFU in the product, 10,000 CFU in the product. And this really, in the minds of some on the regulatory side, has called into question whether or not 100 CFU is an appropriate standard. And I ask as a risk manager, if it's not 100, maybe it's not 0, maybe it's something else, but what is that? How do we determine what that is? Another thing that, another event that drove changes was the bluebell outbreak, and I think this was already referenced in this discussion, but in the case of the bluebell outbreak, the FDA was able to analyze a large number of samples, and they found that first of all, 99% of the samples they analyzed were positive, so the consumers had a high level of exposure to positive units, which could have been a factor. That's an open question. The levels were relatively low. There were a couple cases where the levels were higher in the samples analyzed. And so this called into question also the 100 CFU per standard, and also raised some other questions about the risks of contracting listeriosis. In the end, there were 10 cases identified over several years, so the incidence was actually quite low. But nevertheless, the FDA was able to identify that there were cases which appeared to have relatively low levels of Listeria that caused illness in some of these individuals. And there's also questions about the dynamics of the environment or the process, the equipment in which they were handled, the blenders and the refrigeration. So this has changed in the U.S. This has reinforced a criterion, an absence criteria, I would say, for Listeria in all ready-to-eat foods. And so, as a risk manager, we need to make sure that those products that we traditionally manage Listeria in, you know, ice cream, ready-to-eat, frozen and chilled foods, that we manage Listeria in those products. But there's also an expanding paradigm here in that now we're seeing issues with dry products, and technically they're ready to eat too, but we never in the past really focused on Listeria management in dry products. This was not something that we would spend time managing it in the environment. We would manage water. We would try to manage factors that control salmonella, but we really didn't focus so much on Listeria. And so the question is, do now I need to have a Listeria monitoring program, or is just managing water and traffic control for salmonella sufficient to also control Listeria? So if I think about risk management in general, I'm going to pivot now a little bit to risk management. If I think about how I approach risk management, I always pull up this equation, and many of you are familiar with this. This is, I call here the ICMSF conceptual equation. It's in several of the ICMSF publications, and it's an equation, and I don't like math, that's why I'm a microbiologist, but it's really a logic equation. So first of all, we look at the initial levels in the raw material, minus all of the sums of the step in our process that can reduce that level, plus all of the things in the process that can increase the level. That could be the environment, that could be growth during processing or storage or distribution. Those all need to be left less than what I've established is my target or my objective in the finished product. And that could be established by a food manufacturer, that could be established by a regulator as a food safety objective or as a performance objective, or as Dr. Betts was discussing earlier, as a performance standard. And so this is a nice logical way to approach how we establish or how we tackle what the expectations are in the finished product. And this is a more detailed diagram of a typical food process and where we can apply performance objectives in order to meet whatever my final objective would be for the product. And so at each of these steps, once we know what we need to achieve at each step, we can identify what those control measures are that I need to put into place to achieve those performance objectives. And then I can, if necessary, I can establish criteria that can help me evaluate or verify whether or not I've met those performance objectives. So it's a very logical way of approaching the management of risk in my products. And I want to talk about criteria here. And I know Dr. Buchanan talked a lot about distributions and the establishment of criteria, so I don't need to go into that detail here. But I want to talk a bit about what criteria mean and how I interpret these and use these as a food safety manager. This is from the Australia-New Zealand standard. It's an older slide, so it may not be the current standard, but this is a good example. I selected this because this is a good example of a comprehensive criterion that has not only a list of pathogens, and in some cases you could consider hygiene indicators for cereal for infants. And I wanted to point this out. You've got N, which is the number of samples, and in some cases you have a 3-class plan, so you're able to accept some that are in the marginal range between little m and big M. And then you have your hygiene indicator of total plate count in this case. So it's a good example of a criterion. So we know, though, that criteria are not, the testing of products and testing of raw materials by themselves are not sufficient to manage risk. And certainly they're not sufficient to see if the product is free of the pathogen that we're looking at or is within spec for our hygiene indicator. And this is a statistical table from ICMSF that shows what the probabilities of acceptance are of various lots with various proportions of defective units. So if you look, and I don't know if I'll try this one, it's closer. Okay, so if you look at 5 samples, remember the Australia-New Zealand sampling plan was 5 for Listeria and 5 samples for Clostridium perfringens and Bacillus cereus in this case. So let's look, what did I do? Okay, I'm not technologically literate here. So with those 5 samples, if I have 10% defective, 1/3 of those lots I'm going to reject, 2/3 I'm going to say they're okay because I didn't see the defective units. If I'm looking at a 2% defective units, which is still in some processes is a relatively high level of defective units, 1 out of every 10 I'm rejecting, and 9 out of 10 I'm accepting. So 9 out of 10 times, 90% of the time, I'm thinking that lot's okay because I'm not seeing these 2% defective units. And I'll tell you, if we look at chocolate, if we look at a dry product, that's actually still a relatively high number of defective units if we have a sporadic contaminant. We're not going to be able to find that contaminant through use of testing. But as a food safety manager, if I'm looking at a criterion like this, I'm not trying to manage to where only 5 samples in my production, in my process, only 5 samples in my lot are positive. I have to manage it so every time the lot is sampled, you do not find the pathogen in my lot. So when we talk about risk managers will say, okay, well this is only less than whatever 5 by 25, 1 in 5 by 25 grams, and that's what we're managing to. As a risk manager, I have to manage to where there is no Listeria in my product because I need to manage to where any time I or my customer or the regulator samples this product, there is no Listeria in my product. So as a risk manager, that's the only option I have. Now I can choose a sample size that has the stringency with which I want to verify whether or not I've achieved that based upon various factors like the likelihood and the distribution. But I need to make sure that every time, particularly if I have an absence criteria, every time I'm achieving this, and how do I do that? There'll be some discussion tomorrow on the various standards for Listeria, so I won't dwell on that, but just to say that we also have some complexity when we have standards that vary from country to country. So sometimes, right now we have, and Listeria is not the only example, I'm going to talk about pesticides as an example in a minute, but we have several examples where there's inconsistency, and this can cause some challenges also in managing risk, particularly if we have a supply chain that is multinational. There's other considerations when we establish and interpret criteria. It's whether or not the sampling plan can really differentiate acceptable from unacceptable lots, and I talked about that if we've got a low level of defective units. We have to look at the distribution within the lot. It may be unevenly distributed, and maybe sampling can capture that contaminant. We need to look at whether or not I can even afford to sample enough units to give me confidence in the absence or the management of that hazard, and then also need to look at the history of consistency and compliance. And the net of that is not that microbiological testing is not useful. It is useful, but it is not a control measure. What we have to rely on is an understanding of the hazard and an understanding of the product and process to see where we need to control risk. And then we have to rely on our management of those controls and verifying those controls whether or not I can do sampling on finished product practically, I still have to rely on those control measures, because that's really where I can have confidence that I'm controlling risk, whether it's a zero risk environment or not. And so the next slides, I'm not going to go into detail, but these are just a summary of some of the big bucket areas, I guess, that you would see in any Listeria guidance or Salmonella guidance that's available through industry associations or in publications or through the FDA or FSIS. You need to have validated processing steps if those are required for safety. You might have process formulation controls. You need to make sure you identify sources of contamination so you can eliminate them in your cleaning and sanitation program that uses appropriate chemicals. You need to make sure that you take into account maintenance activities and managing those to make sure they don't result in cross-contamination or create harborage opportunities. You need to look at personal hygiene with food workers, particularly those that are in contact with processing equipment or food products. You need to make sure you manage packaging. Primary packaging needs to be protected from environmental contamination because it touches the food. You need to make sure that if there's factors in storage and distribution that can cause risk, if it's a perishable product in particular, that those are managed. You need to look at operational issues such as humidity and moisture control, air quality and ventilation, zoning, traffic patterns in the factory. So there's a lot of process-related controls, but then also just making sure you account for side processes such as rework, management of inedible material, and that you don't have niche environments where pathogens can avoid cleaning and sanitation processes. And also you need to have an effective program to verify environmental controls as well as controls in your product and process. But I want to talk now a little bit about produce, because I come from, up until a few weeks ago, a manufacturing operation. And we had some processes that were similar. If you look at confections, if we have a chocolate factory and we're bringing in cocoa, the supplier might manage some of that risk. But I in my factory am still supposed to, in all of my parts of the operation, a confectionery factory, I need to manage salmonella harborage and the recontamination of the product with salmonella, and oh, by the way, Listeria, to make sure that I am managing that risk of recontamination. So those are a lot of soft controls and environmental controls, and testing by itself is not going to, as I've said, testing by itself is not going to assure that those controls are in place. But for produce, it's similar, but a little bit more tenuous, because we don't have those absolute controls for fresh produce. We have some things that can lower the risk. We have some things that can manage the sources of contamination, but we don't have a kill step. We don't have a roasting step or a retort step. We have to rely on a variety of control measures to work together. So some examples, you can, if you can apply some of these processes, that's great. But it's usually a combination of control measures such as minimizing, and this is for Listeria, minimizing Listeria in the field, looking at hygienic design of equipment so you're not recontaminating. You can sanitize maybe the surface of produce in some cases, making sure you have appropriate cleaning and sanitation, that you have zoning maybe in your process but out on the field so people aren't walking, people on the farm are not walking from higher hazard areas to areas close to the fruit, practices of personnel. But I listed up here some of the things that you need to manage in the field, because you may not have the ability even to wash the surface of some produce. So what do you do in the field? And Listeria is ubiquitous. So how do we minimize Listeria? I don't know if we can eliminate Listeria, but how do we minimize Listeria in these products? And these are some of the things that could be sources of Listeria that we need to manage in the field as we're growing produce. So you can see there's a lot of these controls that need to all work together, but none of them are things that you can absolutely assure that can eliminate the risk. You just need to make sure that you have evaluated the risks and make sure you do your best to minimize the risk of contamination. I want to spend about 2 minutes now just talking about pesticide MRLs, because we talk a lot about microbiology, but I want to say that we could talk about allergens and zero risk for allergens, which is a big challenge, and that's a whole other talk. I don't know if I don't think there's allergens in the meeting for allergen tolerances, but I think last year we had some discussions on that. But allergens is also a real issue, but I bring this one because this is near and dear to my heart, and anybody that has worked on the produce side either with their suppliers or as a produce manufacturer. And it's the issues of the maximum residue limits for pesticides. And we know that when pesticides are applied, there's a number of things that happen to pesticides. They could get incorporated into the plant, but in a lot of cases they may get dissipated. So there's factors such as when the pesticide is applied that are important. There's factors such as what's going on in the neighboring field that are important. As an importer, though, you have to worry about maybe where that material is coming from, because that can also impact whether or not a pesticide is present, and that's what I want to dwell on here. This is a case of carbendazim in orange juice, and I don't know if any of you recall this. This was where the FDA on importing orange juice into the U.S. from Brazil found carbendazim, which is legal in Canada and legal in Brazil. It's not legal in the U.S. The way that the pesticide system works in the U.S. by regulation, and in other countries as well, is that the pesticide manufacturer needs to register the pesticide with the company that, or with the EPA, to show in a risk assessment with data on exposure and evaluation of the hazards associated with the pesticide, demonstrate that it's safe for that commodity. But if they didn't at the time think that it was going to be used for another commodity, even if it's similar, it's still not approved. It's only approved for what they filed with the EPA. So what we end up with is maybe some pesticides that might not be normally used in the U.S. because we don't have particular pests, that are now an issue because we're importing from other countries that have that pest and may need to use that pesticide. And it's a complex exercise because it's expensive to register pesticides, and sometimes the manufacturer doesn't really have incentive because they have a new pesticide and they don't have incentive to register the old pesticide. So it can lead to some real complexity in international trade in particular, and for multinational food companies, this is a real challenge. And a lot of the issues that we see in our contaminants programs are pesticides. So this is, for tea, is an example that's also relevant because the U.S. and Canadian Tea Association have been working on pesticide MRLs, on increasing the list of pesticide MRLs. And you can see for U.S. and Canada, there's not a lot of MRLs. But even the ones that are there are very different than Codex, and they're very different than Japan and Australia, and there's some more listed there. So the question is, how do we tackle this? Do we just live with it, or do we try to address it? And I wanted to show this as an example because it's an example of what we can do proactively to improve the situation where we have an unnecessary zero tolerance, I guess. So if the pesticide's not approved, the only level of relevant is absence. And here, there was an interagency or intergovernmental group through FAO that was established to address this inconsistency. And in the U.S. and Canada, the U.S. and Canadian tea associations are working together in order to manage this risk, or order to increase the number of pesticides that are allowed for tea in Canada and the U.S. And they've been very successful. And I'll show you here. This is only 2014, so there's been a number added since then. But even by 2014, you went from 3 allowed in 2008 to 20 allowed in 2014. And that's not through it's not through making a different case for risk, it's through actually doing the homework to try to get the risk evaluations done so we don't have to deal with zero tolerance. In Canada, you see that several have been added. There was at this point to be 3 more added. They're already above 26, and now these groups are working with chemical manufacturers to find other ways to increase the list. So that's another strategy to manage to these zero risk standards, is to try to change the standard through the collection of data.
You have time.
Okay, yep. So with that, just to summarize, we can how we manage risk, to establish processes to understand consumer behavior and reasonably expected misuse. We can use the full chain approach, as I mentioned, to identify risk factors and to develop effective control measures. We can develop an appropriate criteria and verification strategy. We can work with industry and regulatory stakeholders to conduct studies to inform risk assessments, and we can work with stakeholders to harmonize standards. And that, I understand, I'm probably more than out of time. So thank you for your time.